Hello everyone. Today what I want to do is quickly go over some of the key points and most of the solutions to our first chapter test. This does not have to be all that we do in terms of getting a feel for what we might have done correctly or incorrectly, but at least it's a start. So your goal is to take what you have turned in and already has been graded and kind of compare to what you see here. And then bring to class any questions that you still have concerning any of these problems. I may skip a few if they didn't really cause an issue for many students, but let's get started. First one, the focus here was to find K, and you were given that it was a geometric sequence. So you were given three terms of a geometric sequence. K had to be between 0 and 5, that's important. And because it's a geometric sequence, one thing we know is that the 3K over k plus 1, k squared plus 5 over 3k, the term divided by a previous term must always remain the same ratio as we go through the series. So simply by making this a proportion, which most people were fine with, we were able to get a cubic, cross-multiplying, solving, setting it equal to 0. Now, when we got this, people did some magical things and wasted a lot of time. Just use your silly calculator and get an answer. It's 1.36. There are other answers to this, or solutions, but they're not between 0 and 5, so you wouldn't take those. So a lot of lost time by not using your calculator appropriately. And we do have a calculator in this course, unless I specifically say you can't use it. The next one, we were given three consecutive terms of an arithmetic sequence. The key here is the setup. I can let them be A, B, and C, or X, Y, and Z, but then we're adding more variables than we need. Some might have started with A plus D, and A plus 2D. That would also be fine. There's no problem with that. But there's a benefit to setting it up this way. One's A, the other one's A minus D, the other one's A plus D. Because then, if we know the sum is going to be 18, which I think is what we're given, we know 3a is 18, a is 6. It's immediate. If we set it up a little bit differently, this would just be an equation with a and d. Next, we know the sum of the squares is 396. So we have this expression, but we already know what a is, so we find the common difference to be either plus or minus 12. And since I just wanted the three numbers, it didn't matter which order you put them in. So in this case, the numbers are negative 6, 6, and 18. And we can check that work, what the sum might be. The sum is definitely 18. The sum of the squares being 396. So three different variables was unnecessary and quite honestly led you to something you couldn't solve. But we didn't need to use three, two at the most. For number 3, we want the sum of the integers between 1 and 1,000, which are not divisible by 4. So the idea here is going to be more of a subtraction idea. I first of all want the sum of the numbers from 1 to 100. So if I take the numbers 1 plus 2 all the way to 100, we already know that that's going to be the 100 over 2 times 1 plus 100, which we know is 5,050. That was one of our basic introductions to an arithmetic series. Now, the ones that are not divisible by 4, well, I want to go with the ones that are divisible by 4. And that's basically 4 plus 8 plus ... all the way to 100. Well, that's going to be just 25 numbers over 2 and 4 plus 100. And then if we do this little calculation, I think we get 1,300. So these are all the numbers, the sum of all the numbers from 1 to 100. These are the sum of the numbers divisible by 4 from 1 to 100. So the ones that are not divisible by 4 would be that's 3,750. I've tried to emphasize as much as I could this idea of coming kind of through the back door as far as getting an answer. We're not actually counting them all. I'm counting everything and subtracting a set with leaving what I want. Right, number 4, there's not a lot to it, so I'll just kind of write the solutions. 3-digit number assuming only odd digits, we got our 3 spaces, simply a 5 times 5 times 5 for 125. For part B, each number can only be used once. That's my 5 times 4 times 3, and that's 60. Now the next bunch is there in descending order. Well, the idea here is imagine like little cubes or marbles or something with numbers on them. And you want a 3-digit number. You're basically just picking 3 of those. Once you get them in your hand, you can put them in order. So that has nothing to do really with the problem. It's just picking 3 of the 5. And we get 10. So that's our first page of the test. We then move on to another kind of subtraction idea. We want how many integers between 1,000 and 999 does the digit 5 occur? Well, I'm going to borrow the same thing from 3. I know there are total 9,000 digits from 1,000 to 9999. And then I'm going to subtract no 5s. So it's going to be 9,000. Now the way to get no 5s is to think of a 4-digit number. We can't use 0 to start, so there's only 8 to choose from. And after that, we can't use a 5. So here we can't use a 5 or an 8. Here we can use anything except a 5, except a 5, except a 5. And then we do that calculation, and we get 3168. The other option is to just go through way too many cases in order to get the answer. Number 6, factoring this, I can write it as n minus 1 factorial factored out of the numerator. What would be left is n minus 1. Since the bottom is n minus 1 factorial, that all leaves n minus 1. Okay? 7. In the one video I gave, I believe I gave something very similar to this. How many diagonals in a 17-sided figure? If you even attempted to start drawing a 17-sided figure and counting the diagonals, I feel sorry for you. Even if you attempted to try to look for a pattern, that's great in an investigation, but we have more powerful, efficient methods. The idea, of course, is that I've got 17 dots. I'm not going to draw them all, but 17 vertices. Any 2 of those vertices make a diagonal, and it doesn't matter the order. Whether I pick A and D or D and A, it's still the same diagonal, so it's a combination. So I'm just going to have 17 choose 2. However, some of those are actually sides. And how many? 17. So we end up with an answer of 119. Third one, where that subtraction idea is very important. Number 8. I got a feeling I'll get some pushback on this, but we'll talk about it first. In number 8, we have a committee of 5 to be chosen, and we have 6 doctors, 3 dentists, 7 others that are, of course, neither doctors or dentists. We want 2 doctors and a dentist. Well, for part A, I want 2 of the 6 doctors. I want 1 of the 3 dentists, and the rest of them have to come from those 7. And that's 945. For the next, I just want 2 doctors. So I pick 2 of the 6 doctors. And then the rest of them, it doesn't matter whether they're dentists or not. And that's 1,800. You would hopefully at least guess that that would be a bigger number than this one, because I'm not pinpointing what that has to be. And the last part is at least one of the 2 professionals. Well, here we go again. I could just go through cases, or I can take the total number of ways I can figure out my committee of 5, which is 16 people choose 5, and I'm going to take out a case where the rest of them, all of them, are from the 7 other. So it's a combination of 7 choose 5. And we do that calculation, and we get 4347. Now, a quick little talk about this. When I say 2 doctors and 1 dentist, there was some evidence that some people thought, well, if I have 3 doctors, then I have 2 doctors. Well, that would be a problem mathematically. And no matter how much critical thinking you might try to use or argument you might try to make, if there's a set of 6 people here and 3 of them are doctors, and you come to me and say 2 of those people are doctors, you're not telling the truth because there are 3. 2 is not the same as 3. So we have to get clear on some of this language. If I say 2 doctors and 1 dentist, I mean 2 doctors and 1 dentist. Not 2 doctors plus some of the other one could be doctors. That's not 2 doctors anymore. We can talk about this in class if we need some more explanation on that. Okay, the last couple. In number 10, you want the constant term of this expression. And it's just a little variation of one we've done many times. So the first thing to do is to figure out the constant term. And then eventually we want it to be negative 10.5. Well, to figure out the constant term, I know it's going to be, actually that's 9, sorry. 9, choose R. This is kx to the 9 minus r, and this is 1 over radical x to the r. And we just do a little bit more work. This is going to be k to the 9 minus r. The x terms we obviously want to go away, so if we separate it, and then the x is going to be 9 minus r on top. The bottom would be half r. We want, obviously, that to be a 0. So r is going to be 6. Once r is 6, then we can go back and find what this is going to be. That's k to the 3rd. So k is the cube root of negative 10.5. Right? But this is a big key. We knew that had to be 0, and we found r to be 6. So if you got r to be 6, you got at least half the credit. Then depending on what you did after that, you could get the rest of it. Okay, the PMI, as I said, is good, so I'm not going to go over that. But let's look at this very last one. And I'll try to squeeze it down here somewhere. I'm going to erase this one real quick. Hopefully you've copied it down. In number 11, we want the coefficient of x to the 5th. Well, the key is to realize which of these terms would then be coupled with these terms to get x to the 5th. And of course, that's going to be an x to the 5th and an x to the 4th. I need them both. To get the x to the 4th, because that's the second term, r would be 4, we would have the combination of 10 choose 4 times negative x to the 4th, which gives me 210 x to the 4th. If r is 5, we'd have the combination 10 choose 5 of negative x to the 5th, and that's going to be a negative 252. So just expanding 1 minus x to the 10th power would have these two terms in it. Now we have to ask ourselves, how am we getting x to the 5th? Well, if I take x and multiply it by 210, x to the 4th, I get 210 x to the 5th. And then if I take 2 and multiply it by negative 252 x to the 5th, I get negative 504 x to the 5th. And we go ahead and subtract those, and I hopefully get negative 294. So I get an answer of the coefficient being negative 294. So most of it involves counting. There are a few series problems early. A lot of it is the counting and the factorial notation, and then we moved into the binomial theorem. Again, use this as at least a start to kind of assess where things might have gone wrong, either in terms of calculation or interpretation. And then when we come to class and meet again, if you want to bring up any of these questions, we can talk about them further. We can do that. Other than that, we'll see you soon in class, and have a good day.